In this module, we will again talk about the microbial growth kinetics in fed batch culture. So as we see in previous module that during the fed batch, flow rate and the dilution is very critical. So at the time during the fermentation process, as well as the time will progress, dilution rate will decrease or increased. Mean the addition rate, the flow rate, if the flow rate or the dilution increase and decrease, that can be expressed by this equation as you see here. So if the dilution rate will decrease as the volume increase, and the D will be expressed by this equation, D is equal to F is the flow rate and V naught is the initial volume in the fermentation vessel when we start the feeding. So Ft is the flow rate at that time. So according to monad kinetics, residual substrate should decrease as D decrease, because if we set our feeding strategy according to the limiting substrate, so we can easily say if dilution will decrease, then the residual substrate will also decrease, so resulting in an increase in the cell mass concentration. So if the mu will remain the same, or we can say that mu and D is not equal and the mu is more than the D, then there will be a more concentration inside the fermentation vessel. So the overall we can say that the mu which will operate in fed batch and SR will be much larger than Ks, and we know that Ks is the substrate utilization constant, which we called as monad parameters. So for all practical purposes, the change in residual substrate concentration would be extremely small and may be considered as zero. So thus, provided that the D is less than mu max and Ks is much smaller than SR. So in this stage, the quasi-steady state may be achieved. You have seen in this discussion that how the specific growth rate, initial substrate concentration with respect to the Ks. So if we focus all these parameters during the fed batch, then it can easily be said that that state which we produce, that is known as quasi-steady state. So in this slide, you can easily see that two different diagrams. As concerned the A, this is that how different parameters can be affected in fixed volume. But in case of the B, you can A deal with the variable volume and B deal with the fixed volume. So if we talk about the variable volume first, so SNL, these are the substrate concentration, GLS growth limiting substrate, mean those substrate which directly affect on the growth or on the fermentation process. But there are some substrate which have not directly effect on the fermentation process, which here you can say represent as SN, non-limiting substrate, and X is the biomass. So during the variable volume, and if we have the D is equal to mu, and then we can say that first, when we start the feeding, that there is a small drift in the mu line, and then it become constant. So x remain the constant because our d is equal to mu. So that always remain constant. That only disturb when the dilution or a flow rate will be disturbed. So Sn, because that only remain the constant, because having no utilization or no effect on that. And the whole strategy of the feeding and fed batch depend upon those substrate which we called as GLS. So by this graph you can easily see that how different parameters varied during fed batch in variable volume. But in case of this another diagram, you can see that there is a constant decrease in a mu, but there is a constant increase in biomass concentration, because when we are having the addition of the substrate and no change in the volume, what happen? The mu remain the same, and there is a continuation addition of the extra biomass in the same volume. So the overall concentration of that remain increasing. So you can see that there is the same appearance of those substrates concentration which are growth limiting, because our feeding strategy mostly focused upon this, we can say that GLS, growth limiting substrate. But in this case, when we say that those substrate concentration that have decreasing rate, because we are not adding that, because we are adding those only become the limiting, because those substrates which are not limiting, there is no need to add, and then their concentration gradually decreased. So the major difference between the steady state of a chemostat and the quasi-state of the fed batch culture is that mu is constant in the chemostat but decrease in the fed batch. Why that is decrease, and why in a chemostat that remain constant? So when we say that mu is equal to D, so then there is no more change in the biomass concentration. dx over dt is equal to 0. That only possible when we say that residual substrate is also 0. So if there is any residual substrate we are adding in such a way that there is the increase in the residual substrate concentration, then there is a gradually increase of those substrate. So fed batch culture can only be run, so the feeding can only be happened when there is a volume provision of the fermentation vessel. So we know that the maximum volume of the fermentation vessel can be utilized 75% of the total volume. Suppose if the fermentation vessel is total having the 10 liter, and we can maximum utilize the volume 7.5 liter, because the head space is very critical. That is needed for the gaseous exchange and some foam control, etc.